Guys, if you are confused like I was about what structural load to take in the Staad Pro, and are we really considering the actual live load in the stat? If this question struck your mind, then please stick with me so that we can jump right into the topic. In our previous video, we have discussed how to design G+2 residential building using Staad Pro Select Series 6 in detail with the following building properties and building materials. If you want to check out this tutorial, you can I have provided a link in the description below. You can just click on it and proceed. But in this video, we are going to discuss about how the actual load is taken in the Staad and why the earthquake load is applied differently in Staad. We all know that we have to start from the basics, so let's just dive into it. Firstly, there will be an excavation carried out, and there will be a footing layout plan, and on top of it there will be a wall foundation. We should keep in mind that the plinth beam will be resting on the wall foundation. So knowing that, we can reduce significantly the amount of reinforcement in the plinth beam. If you want to see the sectional detail of the wall foundation, here is the one I provided. This is actually from my personal drawing. And for the footing also, you can see the plan and this section. From here we can see the reinforcement layouts. Now if we look into the dead load, that is self-weight in the Staad. That is basically the self-weight of the frame, which will be the beam and the columns. The load contribution from this slab we will consider later on with the floor loads. But we can model this plate in the initial phase, and we can neglect the contribution later on with the floor loads. But personally, I feel much more comfortable just by doing with the frame in the beginning and considering the contribution from the floor load later on. This is just to give you an idea about the reinforcement at the junction. Now if we look into the floor load to take in Staad, firstly the roof load. Roof load, there will be a timber structure instead of RCC slab. The timber structure will basically be the timber battens on top of which there will be a 35 mm lap joint timber planks, and this can vary, but the overall timber structure will be very light, and the load contribution comparative to the RCC slab will be very less, so that so this is why we can neglect the load contribution from the timber structure in the Staad. But in this two intermediate floors, we have to consider the load contribution because there is a RCC slab. Now coming to the general dead load. In our previous video, we have the slab that is for we have considered the load contribution. Now coming to the general dead load, we have the slab that is from the load contribution from the column and beam. We don't have to consider because it is just filled up with different material, and the load will be directly resting on the earth. If you want to see how the different material are filled up to the dead load, you can see it here. Now coming to the dead load, we have the load contribution from the slab, that is the floor load we take in the Staad, and for the column and beam, that is the frame self-weight that we take in the Staad, and for the wall load, that is the wall load that we take in the Staad, and for the roof load and staircase we have not considered in this project, but in the real life project we have to consider these two, roof load and staircase. Now how do we consider the member load in the Staad? If you look at this example, the wall height is 3 meter, thickness is 0.25, and density of wall is 20 kN per meter cube. If we multiply all this, we get the external wall load from contribution from external wall is 15 kN, and from internal wall is 9 kN per meter. Now load contribution from the slab. If we consider this example, thickness is 115. As per IS 456, the unit weight of RCC slab is 25 kN per meter cube. Multiplying those two, we get 3.75 kN per meter square. Now coming to the earthquake load. As per IS 18. Now if we look into the earthquake loading, as per IS 1893-2002, from the clause 741, the weight of the columns and the walls shall be distributed equally in above and below story. What it means? It means that when the earthquake happens in horizontal directions, if we consider this point, the load contribution will be from this portion, which means that the mass of the wall, half of the mass of the wall above that point and half of the mass of the wall below that point will be contributing to the force, to the horizontal force in that point. We have another clause from the same code, that is 743, the weight of the story shall be distributed to the story above and below proportionately according to the distance from the floor. The same concept applies to this clause also. Now if we see the imposed load from the earthquake loading, as per IS 1893-2002, we don't take the full load of the imposed load. We can see that only up to 3 kilonewton per meter square we take only 25% of the load, and above 3 kilonewton per meter square we take 50% of the imposed load. Why is it? It is because when the earthquake happens in horizontal direction, we see the sliding effect. That is the imposed load is not able to contribute its full load to the frame. That is, the sliding effect happens between the slab and the furnitures or the imposed load, thus reducing the horizontal force. So this is all. Thank you for subscribing, and if you want to see more videos, please subscribe.